Hello everyone, this is Ashoke, your personal guide and mentor. I welcome everyone to my YouTube channel AKB Tutorials. Here we are going to discuss and cover some important concepts of mechanical engineering that are very useful and helpful for competitive exam and job interviews. So let us start today's session. Hello everyone. So today we are going to learn one of the most important topic of strength of material, that is load and its classification. So this load and force, the two terms, that is load and force, these two terms are invariably used in so many subjects like strength of material, machine design, engineering mechanics, structural analysis, or other subjects of mechanical engineering. So today in this video we are going to learn what is load or force. Okay, so load is equal to force or force is equal to load. So now force. What is force? It is the external agent which when acts over a body, either it will tend to move the body or it will move the body. So that means, say this is the body. If the body is under the influence of some force, say P is the force acting on the body, because of that influence either the body will move in the direction of force or it will try to move the body. Now the definition of force is obtained by Newton's first law of motion. Newton's first law of motion. So as far as the statement of Newton's first law of motion, everybody continues to be in the uniform motion, the same straight line, or at rest unless it is compelled by some external force. This some external force, the definition of force, is obtained by Newton's first law of motion. And the measurement of force is obtained by Newton's second law of motion. So now, what is Newton's second law of motion? The rate of change of momentum is directly proportional to the applied force and acts in the same direction. And mathematically, it is given by P is equal to mF, where P is the force applied over the body and m is the mass of the body and F is the acceleration produced in the body. So now this load or force are the same term, and the definition of force or load is obtained by Newton's first law of motion, and the measurement of force is obtained by Newton's second law of motion, and mathematically it is given by P is equal to mF. And if we see the units, the unit of force is given by Newton, kilonewton, meganewton, or giganewton. Now what is Newton? It is that force or the amount of force when it is applied over a body of mass 1 kg produces an acceleration of 1 meter per second square. So that force, so Newton is that force when it is applied over a body of mass 1 kg produces an acceleration of 1 meter per second square. So now kilonewton, it is a bigger unit and it is equal to 1000 Newton, and meganewton is equal to 10 to the power 6 Newton, and giganewton is equal to 10 to the power 9 Newton. Force is a vector quantity, the physical quantity which is expressed by its magnitude and the direction is known as vector quantity. So force is a vector quantity. Now we will see the various classification of loads in various aspects. So now we will see the classification of loads. So according to various aspects, loads are classified. So the first classification, it is according to its nature. According to its nature or nature of load. So first classification is according to its nature. According to this, the load is classified as dead load and live load. What is dead load and live load? Live load. So first one is the dead load. So this kind of loads are permanent and will remain at same location throughout its life period. So that kind of load is called dead load. The load which remains at the same location and permanent. So for example, that is the weight of structure. So that is the load is called dead load. Now the other kind of load as per this classification, that is live load. The load which is not permanent and continue to move throughout its life period, like weight of man or weight of furniture. So that does not remain at the same location. So that means this kind of loads moves throughout its life period. Now next classification based on the basis of fixity. On the basis of So according to this classification, loads are classified as static load and dynamic load. And dynamic load. So in this, what is static load? The load whose magnitude will not vary throughout its life period or the period when it is applied over the body. So the magnitude of the load will not vary as long as it is applied over the body. That kind of load is called static load. For example, the dead load what you have seen, so that is coming under the static load. Second kind is dynamic load. What is dynamic load? The load whose magnitude varies with time. So that kind of load is called dynamic load. Next classification we will see according to the direction of application. According to the direction of application. So according to this, loads are classified as, first kind of load is the tensile load, and second kind of load is compressive load, and third kind of load is shear load. Now, if we see the first kind of load, say a body is under load P and the direction of the load is shown in the figure. So, if this is the direction of the load, it will cause the extension of the member. So, the load which causes the extension of the member is called the tensile load. That is, the size of the member will increase because of this kind of load applied over it. So, that is called tensile load. Now, second kind of load is the compressive load. If the direction of load is such that the compression of the member will take place, then that kind of load is called compressive load. Say this is the P. If the direction of load P is like this, as shown in the second figure, then the body will compress, means the length of the body will decrease. Then that kind of load is called compressive load. And third kind of load is called tangential load. Say this is the body. If the load is acting over the body on a surface tangentially, so load P is acting tangentially on a surface. So this load will change the shape of the body, or because of this load the shape of the body will change. Say initially the body was given by ABCD. Now after the application of the load, the shape of the body changes to A, B, C dash, D dash. So this is the shear load. Now next we will see the another classification, that is according to the effects produced in the body. So this is the next classification, that is fourth classification. So according to this, the load is classified as bending load and shear load, bending load and torsional load. So the first kind is the bending load and second one is torsional load. So consider a beam, a simply supported beam. The beam is under load P, a transverse load P is applied over the beam. Because of this load P applied over the body will deflect like this, or in other words we can say the deflection of the body will take place, or bending moment or bending stress will develop in the beam. Okay, so that's why this kind of load is called bending load. So because of load P, bending stress is developed in the member. So that's why this load is called bending load. Now in the second kind, say this is the member. The member is under two equal and opposite couple. So that means two equal and opposite couple is acting over the member, or we can say torque is applied over the member. So that kind of load is called torsional load. Because of this torsional load, the shear stress will develop in the body, and because of bending load, the bending stress will develop in the body. Now we will see the another classification, that is according to the area of application. According to the area of application. So according to this, the loads are classified as first kind is point load, second one is uniformly distributed load, and third one is uniformly varying load. So in the first kind, that is point load. So consider a beam, say a cantilever beam, load P1 is acting at this point at the free end. Similarly, say P2, the another load is acting at point, say this point is B point and this point is C point. So in this case, whole magnitude of the load is passing through that particular point. So as we know, point has no dimension and it specifies the coordinates of a location, and it is denoted by putting a dot. Okay, so whole magnitude of the load, say P1 is passing through B and P2 is passing through C. This kind of load is called point load. Now next kind is uniformly distributed load. Say this is a cantilever beam over which the load is acting like this. So it is given by W Newton per meter length, and say the load is acting for a length of x meter from three end. So this kind of load may act for whole length of the member, or the part length of the member, or whole area of the member, or partly it may be some areas of the member. So this is called the uniformly distributed load, where the load value per unit length is equal, or in other words we can say load is evenly distributed over the length it is loaded. Okay, so if it is W Newton per meter length, and we have considered that for x meter length load is distributed, so total load on the beam is given by W into x. And if we consider this UDL, uniformly distributed load, as a point load, then it will pass through the center of gravity, that is exactly at the center of this length. So if we consider uniformly distributed load as point load, what is the magnitude? Magnitude Wx is passing through here, and what is the distance of center of gravity from free end is given by x by 2. So this calculation is most essential for shear force and bending moment calculations. So now next we will see the uniformly varying load. Varying load. So consider a beam, say cantilever beam, and the load is distributed like this. So that means the magnitude of the load is uniformly either increasing, or from this side if we see it is decreasing, and the maximum load value is W Newton. At this point the load value is 0, and the length for which the load is distributed, that is x length, for example x length. So that means the magnitude of the load varies at every point. Then this kind of load is called uniformly varying load. And What is the total load acting on the beam? Total load on the beam. So it is the average load 0 plus W by 2 into the length for which it is distributed. So that means half into x into W. What is half into x into W? This is the area of this triangular portion. Half into x, half into base into height. So that means total load acting on the beam is given by the area of the triangle, and it is half into x into W. That's why this kind of load is also known as triangular load. Now we will see the next classification, that is according to the application of the load on a member. According to the application of the load on a member. So according to this classification, loads are classified as gradually applied load, suddenly applied load, and the last one is the impact load. So as far as the first kind, gradually applied load, so when load value increases from 0 to some maximum value and it requires some time for application of the load, that kind of load is called gradually applied load. Consider a spring. So initially the spring under load 0. Now you try to put some force over it to some maximum value. So that means on the spring application of load will be from 0 to some maximum value, say 0 to F. Okay, and it requires some time. So that kind of load is called gradually applied load, and second kind of load is called suddenly applied load. Consider a table. This is the table, and a heavy load is suspended over the table. Just it is clear of the table, but it is over the table, and it is suspended with the help of a crane hook. So it is a crane hook. Now if any reason, if this crane hook is broken, what will happen? Without taking any time, whole load will be applied over the member. So that load is called suddenly applied load. So in the first kind, if we see gradually applied load, the stress value is given by P by A. What is P? P is the load of the member and it is applied over the surface A, so P by A. Second one is the suddenly applied load. If we find the stress developed because of this, sigma is given by, or we can say stress is given by, stress developed by suddenly applied load is given by 2P by A is equal to 2 sigma. That means the stress developed in suddenly applied load is just double that of the gradually applied load. And next we will see the impact load. So in this, load is falling from some certain height over a member. So in that case, the dead weight of this member as well as the dynamic load because of the movement of this height, say height is h, so both will be applied over the member, and the stress developed because of this is given by sigma is equal to W by A into 1 plus square root of 1 plus 2A H E by W into L. So this is the expression, so you can get the derivation of this from some book. Okay, now we will move to the another classification, that is according to the nature of application of the load, or on the basis of according to the nature of application of load. So according to this, loads are classified as, first kind is axial load and second kind is eccentric load. So if we see the first kind, axial load, say this is the member, and let this is the axis of the member, and load is acting along the axis of the member. So P is the load acting along the axis of the member. Now P is a compressive load, so it will produce compressive stress. So now sigma, the compressive stress, is given by P by the area of the member. So that means because of axial load is compressive, so compressive stress will develop, and if the load is tensile, so it will develop tensile stress also given by P by A. So these are called direct stress. So because of axial load, direct stress will develop in the member. Now if we see the another kind of load, that is eccentric load. So consider a member and let this is the axis of the member and the load is acting at this point, say P is the load acting, but it is not acting through the axis of the member. The load is acting at some distance away from the member, say E is the distance, or is called eccentricity. So now because of this P, what is the effect produced in the body? Now let's see, consider that we are applying the two equal and opposite force equal to P value at the axis. Now forget this 2P, consider this P. This P is acting through the axis of the member. So what it will produce? It will produce the direct compressive stress, that is equal to P by A. Now forget this and consider this one. So if we see separately, this is the P and this is the P, and distance between these two P is E. So that means these two force, equal, opposite, parallel force, forms a couple. Okay, what is the magnitude of this? That is, say M is equal to P into E. So because of load P is not passing through the axis, it will produce direct compressive stress, as well as a moment will also produced along with the direct compressive stress. Okay, so this is all about this, and we will meet soon in the next topic. Okay, thank you. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.